So very quickly in this video, we're just going to cover the last few pieces of section 3.4, part 1, just some of the more detailed problems. Sometimes if you struggle factoring, the calculator can at least help you find the roots, and we'll talk about that with this first problem. By the way, we can factor this pretty easily, and we'll go ahead and do that in a couple moments. But if you do have a problem doing that, factoring, just run into trouble and just kind of run into a roadblock for some reason, you're stumped with a particular problem, your calculator can at least help you find the zeros. It's not going to give you a great idea on factored form, however, but it'll at least get you somewhere. So we're going to take a look at things in this go around, and what we'll see is the function 6x squared plus x minus 2. I've put that into the y1, into my y1, and I've graphed it. And I can see 2x intercepts. Well, how do I find the roots? Well, you have the steps over here. Run second, calc, choose option 2 for 0. I'm going to go ahead and find the x-intercept on the right. So in steps 3 and 4, you just set your boundaries with your cursor. Get somewhere to the left of the root, which I just did. Get somewhere to the right of the root. And now you specified the boundary that you want the calculator to look in. And then all you're doing is, hey, it'll say, hey, do you want me to guess? You say, certainly. Go ahead and guess. And you come back and you're told that the root lives at x equals 0.5 or x equals 1/2. We could do something similar and find the other root. So at least we kind of know where the roots are. It doesn't really help us necessarily with factored form, but at least gives us some type of starting point. But let's look at this problem real quick. Sorry that I have some scrap paper here, but I had done some previous writing. I just want to cover up as we work this through. I can handle this by grouping. I'd be looking for two numbers that multiplied give me -12, added together give me +1. And the numbers to use would be 4 and -3. So I can turn this into 6x squared plus 4x minus 3x minus 2. Grouping tells me what? Look at the first two terms. I can take out a 2x, 3x plus 2 minus 1, 3x plus 2. And I'd have 2x minus 1, 3x plus 2 as my factored form. And I can certainly find these roots. X equals 1/2, gee whiz, that's what our calculator showed us. And x equals -2/3. Both with a multiplicity of 1, which you can certainly see here on the graph. It's just a standard parabola. It should have up behavior, by the way. So, calculator can give us some things. And let's talk about a more specific example that we can use that'll do just that. So on some problems, you're going to be given a relatively complicated polynomial. We're going to let you go to your calculator and find one of the zeros and use synthetic division to get the remainder of the polynomial, which should be something that you will subsequently be able to factor. So let's walk ourselves through a couple of these problems. The first one is x cubed minus 4x squared minus 7x plus 10. I'm going to get that into my y1. X cubed minus 4x squared minus 7x plus 10. Oops, get this camera screen out of the way. You can see that I'm built. I'll go ahead and graph this thing. Now I've made my viewing window a little bit bigger than I want to, so bear with me a couple seconds. I'm going to go ahead and go back to standard form. In terms of zooming, I'm going to zoom standard. And in so doing, I'm going to be able to see some of the roots. And I'm just going to do one more thing. I'm going to zoom in just a little bit, because this way I'll be able to see some of the roots a little bit better. And it turns out I have a root at x equals +1, which means, by the way, that x minus 1 is a factor. I can divide this polynomial by x minus 1, and hopefully I'm going to turn into something that I can work with. Let's try it. So synthetic division would tell me I have no gaps. 1, -4, -7, 10. X minus 1, well, my root's at 1, so remember, always change the sign. If you're dividing by x minus 1, make sure you put a 1 out here. Draw the rest of my synthetic division grid, and here we go. The 1 drops down. 1 times 1 is 1. -4 times 1 is excuse me, negative 4 plus 1, negative 3. Negative 7, this will be minus a 3, 1 times negative 3. Negative 10, 1 times negative 10, negative 10, 0. Beautiful. This is factored into x squared minus 3x minus 10. And by the way, what's my fully factored form look like? It looks like this, x minus 1 times x squared minus 3x minus 10. Can I factor this? I sure can. X minus 1, x minus 5x plus 2. I got all my roots. I got a root at x equals 1, multiplicity of 0. I got a root at x equals 5, multiplicity of 0. I have a root at x equal negative 2, multiplicity of 1. Please forgive me. Multiplicity of 1 in all those cases where my zeros are. Here's my fully factored form. By the way, odd degree, positive leading coefficient. I know my function is going to do something like this. I'm going to have down-up behavior. I also know that 0, 10 is going to be another point that I could actually graph if I was shaping this. So the bottom line is synthetic division serves as a jump start for you to work through these problems. We'll do one more. The last problem that we see over here. Give me a second to just kind of move everything. Clear my y1. 3x to the 4th. Hey, a little bit bigger polynomial this time. Plus 2x cubed minus 16x squared minus 10x plus 5. Okay, so that's what I should look like in my calculator. I'll graph it. Again, I've had my window that's kind of pretty open, so I've zoomed in a little bit, but I notice a root at x equals negative 1. X plus 1 would be my factor. I'm going to divide by x plus 1 and see what happens. Here we go. Make sure that's a negative 1. No holes. 3, 2, negative 16, negative 10, 5. Let's see what we get. Remember to drop down my 3. It becomes negative 3. What I'll have a negative 1 times 3. We already did that, negative 3. 2 plus negative 3, negative 1. Negative 1 times negative 1, 1. Negative 16 plus 1, negative 15. Negative 1 times negative 15, 15. 5. Negative 1 times 5, negative 5. Beautiful. No remainder. 3x cubed minus x squared minus 15x minus 5 is what I'm looking at now. Okay, what can I do here? And by the way, this would be fact times x plus 1. Sorry for the handwriting there. That's just times x plus 1. All right, let's break this down. Can I group it? Yeah, it looks like it. X squared, 3x minus 1 minus, or let's look here. Yeah, minus 5. My fault here. I just did a transposition. I made a negative 5 here. That should be a positive 5. Just had an error there. So minus 5 times 3x minus 1. That's what this piece factors into. I'll put some brackets around. I still have my x plus 1. No sweat. All right, what do I have? X squared minus 5. 3x minus 1. X plus 1. What can I do with this? Well, here comes a root at x equals 1/3. We already knew we had a root at x equals negative 1. Both of these with multiplicity of 1. And finally, x squared minus 5, well, that's going to give us, if we set that equal to 0, x squared is equal to 5. X is equal to plus or minus the square root of 5. So we have two more roots. Remember, these are numbers that I can put on the graph. The square root of 5 is a little bit more than 2. I have two more roots. So I have a root at x equals the square root of 5, multiplicity of 1. X equal negative square root of 5, multiplicity of 1. I have everything that I need. So this was a slightly more complicated problem for sure, but it's one that we can work our way through. Trust yourself. Let synthetic division give you a jump start, If you find one root, use that as your synthetic division element. See what comes out after you do a successful synthetic division. Number one, hey, if you found the right root, you always know that when you divide, it's going to work out. You should have a remainder of 0. So you should be able to factor this and wind up with a second factor. In other words, your division is going to give you something that you can work with. You're not going to have a remainder. Once you're there, just use some of the factoring techniques that we've already talked about throughout these parts, and you're ready to go with the rest.